Okay guys, so here's E13. So in this video, we're gonna do derivatives that involve log base A of x. So we gotta talk about the derivative of log base A of x. Okay, so here's another chart that involves logs. So y equals, so the natural log of x we did last video. So the natural log of x, I'll put its derivative here, is 1 over x. Now from this derivative, we can figure out these two derivatives. So let me just talk about that, and then we'll write the formulas down. Okay, so here's a little review from last year, and I think the year before. So the change of base formula, we did use this last year, like if you had, we mostly had something like this, like if you were dividing one log by another, and I asked you to express it as a single log, you would just write, you would write a single log. Whatever the bottom input was is the new base of the log, and then the top input just went inside. This is called the change of base formula, because we're going from working with logs of base 10 to a single log of base A. So last year we went from here to here a lot. Now in order to show you the formulas, we're going to be going from here to here. All right. Now this change of base formula, guys, can be used with any base. So if you're starting with a single log of base A, you can convert it to this log expression with base 10, but you could also use, like, for example, a base B. So same thing, like log base A of x, I could rewrite it as log base, any base of x over log of any base of A. All right, as long as the A and the x go in these inputs. Now, the way that we're going to use the change of base formula is we're going to use it with base E. So remember, B could be any base, so let's have it be base E, and then that's a natural log, right? Log base E is natural log. So over here we have base A, and then so this expression, this log is equivalent to this quotient of these two logs, like that. Natural log of x over natural log of A. All right, so if I want, I'm just showing where these formulas come from. In the future, we could just use the formulas. So I want to take the derivative of this. So first, let me recognize that this is the same as natural log of x over natural log of A. Now, A is just a number, okay? So I could rewrite this as 1 over natural log of A. This is just a coefficient times natural log of x. Now, when I'm taking the derivative, remember, coefficients just come down. Times, what's the derivative of the natural log of x? 1 over x. So we get that y prime is 1 over natural log of A times x. All right, and that's the formula. Now, the same thing works if you just have a regular log. If they're not showing the base, remember, that's an implied base 10. All right, a regular log is log base 10. So we could do the same thing here. You could convert this to natural log of x over natural log of 10. And then y is 1 over natural log of 10 times natural log of x. And then you do the derivative, so y prime 1 over natural log of 10 times 1 over x equals 1 over natural log of 10 times x. Okay, so the derivative, if you see just a regular log of x, remember that's base 10, so its derivative is 1 over natural log of 10 times x. And then this one, its base is A, so it's 1 over natural log of A times x. All right? Now, all right, so let's do this. So I recommend you don't really need to memorize these formulas, guys, because if you don't want to, because you could just do what so let me do this example like you didn't know, like you didn't know this formula, but you but you knew how to rewrite this using natural logs, okay? So if you didn't, and then for the other examples, I'll use the formulas. If you didn't use formula, you would go, you'd say this is y equals negative natural log of x over natural log of 8. And then you could say y equals negative 1 over natural log of 8 times natural log of x. And then you do the derivative. So y prime is negative 1 over natural log of 8 times 1 over x. So you get y prime is negative 1 over natural log of 8x. Personally, I would prefer to just know the formula. All right, you could have, skipped 1, 2, 3, really like 3 steps if you just like use that formula. So if you didn't want to use the formula, there's your option. This next one, let's use the formula. So what I've got here is, let me think how I want to explain it. Okay, you know what? Why don't we do it like this? Okay, so here's the thing, guys. You could think of this 8, you could just bring it down as a coefficient right now, or you could use it as part of the outside function. Let me think. All right, I'm gonna kind of do that because Logan and I did, I don't know if he remembers, but I did something similar. We did something similar in class today. All right, so I'm just carrying down this coefficient. All right, coefficients just get carried down when you're taking a derivative. And now I need the derivative of this log function. So I ask myself, well, inside the log is not a plain old x. So I've got to do chain rule. So the inside function is 5x plus 2. The outside function is log base 3 of blank. The derivative of this inside function is 5. The derivative of this outside function is, I could just use that formula there. The derivative of that outside function is 1 over natural log of 3 blank. All right? So the blank goes where the x is in the formula. Okay? Now what goes back in this blank is whatever used to be in the original blank. So that's 5x plus 2. Okay? So here's the derivative of this log part. So that is 5 over natural log of 3 times 5x plus 2. So y prime is 40 over natural log of 3, 5x plus 2. Okay? Yeah, so I think the formula is just better, guys, than having to just go through the process the whole time. Now, let's just do one more. Okay? So this one here, this is a product of 2 functions. So I'm going to need the product rule. Now, guys, using these brackets is totally optional. Okay, plus, so you do 4 brackets, plus right in the middle, prime on the first, prime on the last. Inverse tangent of 2x. Log of x squared minus 3x. 3x. Okay. So, for this derivative, I need chain rule. 2x inverse tangent of blank. The derivative of the inside is 2. The derivative of the outside is 1 over 1 plus blank squared. Okay. Now, what goes in this blank is what was in this originally in this blank, which is 2x. So that just goes there. Okay. Now this derivative, also I'm going to need chain rule. So the inside is x squared minus 3x. The outside is log of blank. Remember, a log is log base 10. So you could put a 10 on the base right here if you want. So the derivative of the inside is 2x minus 3. You'll need parentheses around that. That's a binomial. And then the derivative of log of blank, log base 10 of blank, is 1 over natural log of 10 blank. Now what goes back in the blank is what goes in this blank is what was in this blank, which is this original inside. Okay, so y prime equals, so this is the derivative of that first thing, 1 plus 4x squared. And then I just carry down this log of x squared minus 3x plus inverse tangent of 2x just comes down. And then the derivative of this is 2x minus 3 over natural log of 10. Okay, guys, so there it is. If you can skip the brackets, you know, go right ahead. I've been doing these a long time, so I don't use the brackets when I'm doing it on my own. But don't force yourself to drop the brackets if you don't feel, you know, if you don't feel like doing it quite yet. Okay, don't force that. All right, I'll talk to you later. Bye-bye.